My dear students, today we discuss about a new result, that is quadratic reciprocity law. That depends upon M. What is M? M is discussed in Gauss lemma. That is M with the number of least positive residues of p minus 1 by 2 multiples of n, that is n, 2n, 3n, etc. p minus 1 by 2n, and this m exceeds p by 2. So quadratic reciprocity law states that if p and q are distinct odd primes, then p by q into q by p equals minus 1 power p minus 1 by 2 into q minus 1 by 2, or p minus 1 into q minus 1 divided by 4. This is quadratic reciprocity law. It's an important result. For any distinct order primes p and q, p by q into q by p is minus 1 power p minus 1 by 2 q minus 1 by 2. So the proof is heavily depends upon Gauss lemma. By Gauss lemma, we know that n by p equals minus 1 power m. Okay. So here, instead of here it is that q by p. We have q by p equals minus 1 power m. By Gauss lemma, q by p equals minus 1 power m, and p by q equals minus 1 power n. What is m? But m is, since m is an order prime, m complements to, when n by p is minus 1 power m, when p is an order prime, then what do you get? Then m complements to sigma t ranges from 1 to p minus 1 by 2 integer part tn by p mod 2. Agree? According to that argument, q by p is minus 1 power m by Gauss lemma, where m complements to sigma t ranges from 1 to p minus 1 by 2, 1 to p minus 1 by 2 integer part tq by p mod 2. Agree? So what is n? Similarly, n complements to sigma s ranges from 1 to q minus 1 by 2 integer part s p by q mod 2. This is obtained from Gauss lemma. Clear? Therefore, what about p by q into q into q by p equals minus 1 power m into minus 1 power n, that is minus 1 power m plus. So we have to show that. What is m plus n? But m plus n complements to m plus n complements to sigma t ranges from 1 to p minus 1 by 2 greatest integer tq or integer part tq by p plus sigma s ranges from 1 to q minus 1 by 2 integer part sp by q mod 2. Agreed? Okay. Now we have to show that, or now remains to show that this sigma t ranges from p minus 1 by 2 tq by p plus sigma s ranges from q minus 1 by 2 integer part sp by q is nothing but minus 1 power p minus 1 by 2 into q minus 1 by 2. That is what remains to show. Okay. So for, consider a function f of xy. F of xy equals some qx minus py, where x and y are non-zero integers. X and y are non-zero integers. Sorry, x and y are non-zero integers. Z union, z plus union, z minus. Okay, it is non-zero integers. Clearly, f of xy be a non-zero integer. When qx minus py, x and y are non-zero integers, therefore f of xy is also a non-zero integer. As this x takes the values 1, 2, 3, x takes the values 1, 2, 3, etc. to p minus 1 by 2, and y takes the values 1, 2, 3, etc. to q minus 1 by 2. Agreed? Therefore, f of xy takes the values, come on, p minus 1 by 2 into q minus 1 by 2. Agreed? And no two of which values are identical. X takes the values 1 to p minus 1 by 2, y takes the values 1, 2, 3, etc. to p minus 1 by 2. Therefore, f of xy takes the values p minus 1 by 2 into q minus 1 by 2, where no two of which are equal. Why? Suppose they are equal, what happens then? When they are equal, means suppose f of xy equals f of x dash y dash. F of xy equals f of x dash y dash. Or if so, consider f of xy. What is f of xy? That is qx minus py equals q x dash minus py dash. That implies, so it is q into x minus x dash minus of p into y minus y dash equals 0. What is this one? This is a function f of x minus x dash comma y minus y dash equals 0. Means x minus x dash is treated as capital X and y minus y dash is treated as capital Y. So it is f of x y equals 0, where x and y are non-zero integers. So f of x y equals 0 is a contradiction. When x and y are non-zero integers, f of x y is also a non-zero integer. So when two of the values of this x and y are equal, then we have a contradiction. Thus we claim, then we see that f of x y is takes total values p minus 1 by 2 into q minus 1 by 2, and not two of which are equal. Agreed? Okay. Now we count the number of positive values of f of x y and number of negative values of f of x y. Number of positive values of f of x y and the number of negative values of f of x y. Okay. So what is f of x y? F of x y equals q of qx minus py. Number of positive values means f of x y is positive. F of x y greater than 0. F of x y greater than 0 means qx minus py greater than 0. That means py less than qx. That means y strictly less than qx by p. Y less than qx by p means y less than or equals integer part qx by p. Okay. Yes. Therefore, total number of positive value is, what is total number of positive value? Therefore, total number of positive value is sigma x, where x ranges from where to where? P minus, x takes the values 1, 2, etc. up to p minus 1 by 2. So the total number of positive values sigma x ranges from p minus 1 by 2, integer part qx by p. Enough? So what about the negative number of negative values, total number of negative values? In the same argument, we have total number of negative values. What is number of negative values means? Qx minus py is negative. Px minus py is negative means q of x less than py. That means x less than py by q. So what is the total number of negative values? Y ranges from where to where? Y ranges from, so the total number of negative values sigma y ranges from 1 to q minus 1 by 2, s 1 to q minus 1 by 2, integer part py by q. Agreed? Okay. But the total number of positive and negative value of f of xy is, total value of f of xy is p minus 1 by 2 into q minus 1 by 2. You already see this. So total number of positive values is this one and total number of negative values this one, but total number of positive and negative value of f of xy is p minus 1 by 2 into q minus 1 by 2. That means the sum of this one, the sum of these two, sigma x ranges from 1 to p minus 1 by 2 qx by p plus sigma y ranges from 1 to q minus 1 by 2 py by q equals p minus 1 by 2 into q minus 1 by 2. Agreed? Okay. That is, the total number of positive and negative values of f of xy is p minus 1 by 2 into q minus 1 by 2. So means sigma, the total number of positive values sigma x ranges from p minus 1 by 2 integer part qx by p plus sigma y ranges from 1 to q minus 1 by 2 integer part py by q equals p minus 1 by 2 into q minus 1 by 2. Left side is number of positive values plus number of negative values. Right side is total values of f of xy. Enough? Okay. But actually what about this one? That is m plus n. That means m plus n equals sigma, instead of x, here it is t ranges from 1 to p minus 1 by 2, t into q by p plus sigma, instead of y it is s ranges from 1 to q minus 1 by 2, it is s p by q, integer part is p by q. That is nothing but p minus 1 by 2 into, that is nothing but p minus 1 by 2 into q minus 1 by 2. Agreed? So, therefore, p by q into q by p, what is p by q into p by q by p? Minus 1 power m plus n, that equals minus 1 power, what is m plus n? M plus n is p minus 1 by 2 into q minus 1 by 2. What is that we requires here? So p by q into q by p is minus 1 power p minus 1 by 2 into q minus 1 by 2. Clear? Okay. So this is quadratic reciprocity law. For any two distinct order primes p and q, p by q into q by p is minus 1 power p minus 1 by 2 into q minus 1 by 2, and the proof is heavily depends upon Gauss lemma, and we use this idea when p is an order prime, then n by p is minus 1 power m, where m complements to sigma, t ranges from 1 to p minus 1 by 2, integer part q by p mod 2. Okay, right. Now, by using this result or quadratic reciprocity law, we try to solve the problem. Means application of this quadratic reciprocity law. So our question is, determine whether 219 is quadratic residue or quadratic non-residue, or quadratic non-residue of 383. Check whether 219 is quadratic residue or quadratic non-residue mod 383. How? So consider for consider 219 bar 383. N bar P. N by P or N bar P. 219 bar 383. What is 219 by 383? It is, what is 219 actually? 219 can be written as product of two primes, that is 3 into 73. 3 into 73. Therefore, this becomes 3 into 73 bar 383 equals 3 by or 3 bar 383 into 73 bar 383. Okay. Now we calculate 3 bar 383 and 73 bar 383 separately. What is 3 bar 383? 3 bar 383, we have by quadratic reciprocity law, 3 here P and Q are distinct order primes. So 383 and 3 by 383 and 73 by 383. So we can evaluate this 3 by 383 into by quadratic reciprocity law, 3 bar 383 into 383 bar 3 equals minus 1 power p minus 1 by 2 means 3 minus 1 by 2 into q minus 1 by 2 means 383 minus 1 by 2. Agreed? That means 3 bar 383 equals 383 bar 3 into, what is minus 1 power 3 minus 1 by 2? It is minus 1. 383 minus 1 by 2, that's again an odd number. So minus 1 power of an odd number, so it is negative. Agreed? So means 3 bar 383 equals minus 383 bar 3. Agreed? But what is 383? 383 congruence to 383 and 3. 383 congruence to 2 mod 3. If you divide 383 by 3, 2 is the remainder. So 383 congruence to 2 mod 3. That means it is congruence to minus 1 mod 3. Okay. 383 congruence to 2 mod 3 means 383 congruence to minus 1 mod 3. We know that if m congruence to n mod p, then m bar p equals n bar p or m by p equals n by p. Okay. According to this argument, 383 congruence to minus 1 mod 3 means 383 bar 3 equals minus 1 bar 3. Okay, m by p equals n by p minus 1 by 3. But what is minus 1 by p? We have the evaluation of minus 1 by p, minus 1 bar p is minus 1 power p minus 1 by 2. Great? Okay. So what is minus 1 by 3? The evaluation of minus 1 by p, p is an odd prime. So it is minus 1 power instead of p, 3. 3 minus 1, 2, 2 by 2, 1 equals minus 1. So 383 bar 3 equals minus 1. 383 bar 3 equals minus 1. Therefore, from here, what is 3 bar 383? We have 3 bar 383 equals minus of 383 bar 3. What is 383 bar 3? Minus 1. So it is plus 1. Okay. So 3 bar 383 equals plus 1. This one. 3 bar, there is a result. 3 bar 383 equals 1. By the same way, you can evaluate 73 by 383. What is 73 by 383? Again by reciprocity law. Next one is 73 by 383. 73 by 383 into 73 by 3 p by q into q by p, 383 by 73 equals minus 1 power, 1 is 73 minus 1 power, come on, 73 minus 1 by 2 into 383 minus 1 by 2. 73 minus 1, 72 by 2, 36. That's an even number. So 2 into 18 into whatever may be. 2 into 18, 36. So minus 1 power and even. So this is right side is 1. Minus 1 power of an even. Okay. That means 73 by 3, 73 bar 383 equals 383 bar 73. Okay. 383 bar 73. Now calculate 383 bar 73. What is 383 actually? When you divide 383 by 73, then 18 is the remainder. If you try to divide 383 by 73, then you have 18 is the remainder. So 383 congruence to 18 mod 73. Okay. So when m congruence to n mod p, then we have m by p is n by p. So from here, 383 bar 73 equals 18 bar 73. Why? Because of this result. When m congruence to n mod p, m by p is n by p, or m bar p is n bar p. What is 18 complements to, sorry, 18 by 73? 18 bar 73 means 18 means 2 into 9. So 2 into 19 bar 73. By multiplicative property, it is 2 bar 73 into mn bar p, mn by p. Legendary symbol is always multiplicative. 2 bar 73 into 9 bar 73. Okay. That means 2 bar 73 into, what is 9? 3 square. 3 square bar 73. Okay. So what is m square by p? M square by p is always 1. M square by p is always 1. So 3 square by 73 is 1. This is nothing but 1. What is 2 by 73? That is evaluation of 2 by p. Evaluation of 2 bar p or 2 by p is minus 1 power p square minus 1 by h. So what is 2 bar 73? 2 bar 73 is minus 1 power 73 whole square minus 1 by h. So if you calculate this one, this is also 1. 73 whole square means 9 minus 1. So it is 4 by 8 and so on. So it is a even. Minus 1 power even. So it is plus 1. 3 square by 73 is 1. 2 by 73 is 1. So what about this product? Product is 1. Means 18 by 73 is 1. 18 by 73 is 1 means 383 by 73 is also 1. 383 by 73 is 1 means 73 by 383 is 1. So there is the next result. Here 3 by 383 is 1. Also 73 by 383 is also 73 by 383 is also 1. So 3 bar 383 is 1. 73 bar 383 is 1. So what about this product? That is 1. Hence we have 219 bar 383 is 1. Means 219 bar n by p equals 1 when we know the result. N bar p equals 1 when n r p. That is quadratic residue model. Therefore, we know that 219 bar 83 is 1. Hence we conclude that 219 is quadratic residue model 383. So this is the application of quadratic reciprocity law. Clear? Okay. Now